Okay, welcome to the Massively Parallel Brewing Project rough draft presentation. Let's roll. So brewing is a very chemical process. It has a lot of inputs that need to be precisely specified so that we have a consistent quality product. Now brewing is generally hands-on. The brewer is going to be doing a lot of the work himself. So what we're hoping to do here is to automate some of this, make it where we have the chance of human error reduced, more automation, and that will help us get a more consistent quality product at the end of every brew session. So a little bit about brewing, so that'll help us understand what we're trying to do here. On the left, we have the hot liquor tank. This tank is just filled with hot water that we'll use to rinse the grains that are here in the mash tun. In the mash tun, the grains soak in water for about 60 minutes. Now, while they are soaking, this is called mashing, it's very important for the temperature in there to be precisely maintained. So what we'll do, the boil kettle we can ignore on the right here, what we'll do is heat up the water in the hot liquor tank and have a coil, a heat exchanger coil, and attached to a pump so that the wort in the mash tun gets circulated through that heat exchanger and we can heat up the water in the hot liquor tank. This system is called a HERMS, a heat exchange reticulating mash system. It is quite popular with brewing, but it's very expensive and we're building one from scratch. So how did we go about doing this? Well, we have this 41-foot stainless steel heat exchanger mounted in that hot liquor tank, and below that a 5,500 watt electric heating element. We can see it mounted in here. I think it looks quite attractive. We're going to control that heating element with a solid state relay. We went with the solid state because it doesn't have moving parts like a mechanical relay will, and this is going to be turning on and off. We want it to last a while. It was the best choice to go with. Our sensor here is an RTD, the most important part of our system because, like I said, temperature, maintaining that precise temperature is the most important thing. Went with a PT100 high grade sensor that's going to be mounted inside that mash tun because that's the temperature we want to maintain. We're obviously going to have to do some signal processing because that RTD is going to give us a resistance. We need to get it in a voltage that's going to get run into the ADC on the Arduino, where we then pass it on over to our friend LabVIEW. LabVIEW is going to handle the PID for us, and we're going to have a nice little output of what's going on, be able to set that temperature of the mash and have that controller precisely maintain it for us. This is not my most proud VI, but it's a work in progress and I'm excited for the final product on the end. A couple results real quick. Time to boil greatly reduced, having that element submerged in the water with 5,500 watts pushes a lot of heat through the water, able to get it up there in 2/3 the time it did with propane. We also have brew house efficiency. Now the electric, I am estimating, I'm optimistic with this. Haven't brewed, going to brew this coming weekend. We'll have some real data in here, but I am very optimistic that we're going to hit somewhere over 90% efficiency, which is great. Also, everybody's green these days. Fossil fuel usage down by 2/3 because we've cut out 2 of the propane burners. And by the end of 2020, we're going to cut that down to 0% fossil fuel usage because we're going all electric. few references. Couldn't have completed these projects without all of these wonderful tools here. Any questions, you're welcome to reach out to me.